Hello, everyone, and welcome to today's session where we will be talking about whole food plant based eating, longevity for humans and humanity. We're very excited to have Dr. Hooman Yaghoobzadeh and Tim Connors with us today. So, to get started, Hooman, would you like to tell us more about how you wound up knowing so much about this subject?
Through pretty significant family history of vascular disease and did a deep dive into the literature of how what we eat affects our health about 8, 9 years ago. And within that process, convinced myself that, you talk about this, why aren't you doing this yourself? Um, at that point, I did composting and still do everything because I love to get my hands muddy and dirty and put a solar panel on my roof because it was fun and cool, and have an electric car without really being an environmental advocate or an animal rights advocate. But I've sort of come to this not in a way that many folks do, which is through the goodness of their heart, because they are really good people and they care about the world. And although I do all of those things, I've sort of backed into a lot of these things because it just makes logical sense. And so let's talk about whole food plant-based eating, specifically about health. And this is just in the United States, and I think is similar in the rest of the world, even in developing countries where obesity has been not an issue forever, now is becoming an issue. And you can see that our country, the United States, as well as the rest of the world, is starting to get into the 30 to 40% morbidly obese categories. And this is over the past 10 years, what's happening in the United States. As it becomes red, obviously rates of obesity are going up. Why is that happening? One of the reasons I believe, and science has borne out, is the amount of glucose consumption. Sugar is a commodity that has been tracked for centuries. And if you break it down, kilograms per individual per year of added sugar. So this is sugar that's added to food, either as sugar, juice extract, high fructose corn syrup, so on and so forth. You can see easily that the consumption has gone from less than 5 to greater than 50, 60, in fact, kilograms per person per year of added sugar. Sugar has, and I'm not going to talk too much about the scientific reasons why sugar is addictive, carcinogenic, as well as induces aging, heart disease, hypertension, stroke, and a whole host of other things, diabetes, obviously. But this is one of the reasons why the obesity epidemic is growing, and the unhealthy epidemic which is even a bigger deal. These are average cheese consumptions. Again, a lot of these are for the US, but I think they are pretty similar in most of the industrialized world. And the developing world, I have a slide about China, you see is, a couple of decades behind, but their trajectory is very similar as well. We've gone from about 12 pounds per year to greater than 30 pounds per year as of about a decade ago. Chicken consumption, about 20 pounds per year to greater than 100 pounds per year per person. This is what's happening in China, and this curve is starting to go up as economics track Western, or I should say more industrialized countries. So when I say whole food plant-based, what do I mean? Let's talk about what processed versus whole is. And before I go any further, if anybody has questions as they come up, please put them in the chat box. Eliam will be looking in the chat box and she'll interrupt me whenever I should answer a question. Most folks understand processed versus whole, that when you process foods, you have a lot of additives, guar gum, carrageenan, emulsifiers, preservatives, and folks understand that those chemicals often are, somewhat not naturally found compounds. And even though each individual one may have been studied as far as their role in disease and cancer and so on and so forth, they've never been studied in totality and in the concentrations that we really are exposing ourselves to. One of the main differences between processed versus whole foods when it comes to plants is the carbohydrate to fiber ratio. And I like to highlight this because this is maybe one of the most important tools that you can take with you to the supermarket when you're buying bread, pasta, chips, anything that's processed comes in a bag or a box. You look at the total carbohydrate number, that's 21. And I know in the United States, we have these food labels. Most other countries is the same now. And then you have the total fiber, let's say is 3. That ratio 21 to 3 is 7. Whole plants typically have carb to fiber ratios 7 or less, or in that range. And when you process food, you add carbohydrate, so you increase carbohydrate, and you take away fiber to make the food more satiating, broken down quicker to sugar, and therefore more addictive. And so the carb to fiber ratio goes down. So as a result, white bread has a carb to fiber, Wonder Bread, I should say, has a carb to fiber ratio of infinity because it has 0 fiber. Whole wheat bread has a carb to fiber ratio of 10. Breads like Ezekiel bread, Joseph's lavash, like a bread that when you look at, you see the grains and the seeds and it's brown, and will have carb to fiber ratios around 4 or 5. The lower the carb to fiber ratio, the more fiber you're getting per unit carbohydrate. We're going to talk a lot about fiber and how that leads to health of all kinds, but I'll get back to that later. One thing that people don't realize about processed food is that our biggest exposure to processing and the chemicals found in processing is through animal husbandry. And that's because animal husbandry is an extraordinarily industrially intense process that uses lots of different chemicals. If you go all the way back, for example, if you're thinking about meat, you go back to corn, which most cattle is now fed. The way corn is farmed, the pesticides, insecticides, fertilizers, and chemicals that is used in corn farming. Corn gets picked, gets put in a silo to dry. There's another round of insecticides. The silo is lined with plastic. Corn then gets fed to the animals. Animals have antibiotics, pesticides on their skin, growth hormones, and a bunch of other chemical processing so that a cow goes from birth to adulthood in 3 months, as opposed to 3 years, which is the typical time that it takes a cow to go to slaughter. Importantly, 50% of or more of much of animal feed now is animal byproducts. The bone meal, the intestines, the organ meats that is not fit for human consumption gets recirculated back to the animal. There's another round of chemicals, antibiotics, pesticides. If you think about water that's fed to the animals, 200 years ago, an animal would go to the stream, or at best, the farmer would bring a wooden bucket of water to the wooden trough and the animal would drink. Now, there's an irrigation system. When you have an irrigation system, you need plastic pipes, you need chemicals in the irrigation system to prevent bacteria and other contaminants from growing. You need, the pipe fittings need lubricants and a whole bunch of stuff. So there are dozens of chemicals that are getting into animal husbandry, making it into the animal that then we eat. I tried to cut the talk down significantly to have time for questions, but I can, if anybody's interested, share the data that's been presented to Congress showing that we can find trace levels of many of these compounds in animal products that we typically eat, and we can find much of their signature in our body as well. But they not only affect us, they affect our microbiome, the bacteria that live in our gut. And we'll talk about why the bacteria that live in our gut are so important and how they really are part of who we are. Nutrient juxtaposition is important to talk about when we talk about whole foods versus processed foods. And so to introduce that topic, you can think about all of the wonderful things that we know are very healthful in whole foods, like fiber, vitamin C, vitamin E, D, all the vitamins actually. And we know that these foods are healthful, and deficiencies in these foods lead to disease. We also know that when you look at epidemiologic studies and you look at, for example, vitamin C levels, you can correlate higher levels of vitamin C naturally found in people from healthy diets to lower incidence of infectious and viral diseases, for example. But every one of these wonderful nutrients, when purified and processed into its elemental form and given as a supplement, when looked at in prospective, randomized, double-blinded, placebo-controlled trials, sort of modern science, they fail to prevent their intended effect, or they fail to have their intended effect. And that's because vitamin C supplements do not improve immunity. And that's because when you eat an orange, you not only have vitamin C, but you have literally 1,000 other compounds that are presented at the right context with the right amount of fiber, micronutrients, minerals, vitamins, and so on and so forth. And that juxtaposition of these compounds are necessary for the biologic machinery that vitamin C depends on to be effective in the immune system. So very important to eat foods that are whole. So when you look at your cereal and it says you get the 100% of vitamin B and C and D and K and calcium in your special K, that's complete nonsense. And, completely driven by the sort of the way the food system in the USDA is set up, but that's a topic for another day. So whole foods give you nutrients that their processed counterparts do not. So that's a little bit background, processed versus whole. Let's talk a little bit about animal versus plant. And my title says whole food, plant-based. I'm sorry, Eliam, go ahead.
There's a question that perhaps we could take now. I know Tim did answer, but Camille asks, what's a good number range for carb to fiber ratio?
So the lower the better. Natural foods will have carb to fiber ratios around 7. I use 7 as sort of a breakout number. That doesn't mean that you're not allowed to eat foods that have carb to fiber ratios higher than 7. But when I look at a food, if it's a foundational part of my diet, like for example, if pasta is going to be a foundational part of my diet, I try to make sure that the pasta that I have has a carb to fiber ratio that's around 7, 8. There are some pastas, chickpea, lentil, chia pastas, but you have to find ones that taste good. If I go to a nice French restaurant or, a friend's house who's made homemade pasta, I will have whatever they serve me. So, but that's a treat. It's not a foundational part of my diet. And you'll see as part of my slide, I wrote whole food, plant-based plus fish. From a personal health perspective, the most important is the whole foods part. And then the second important piece is the plant part. And I'll talk a little bit about later what I mean by that. I add fish as the one animal product that in well-done studies appears to be healthful, not just neutral, like eggs, chicken, and maybe even unprocessed meat. I don't think those things are necessarily evil or poisonous, but at best, they're neutral foods. They are calorie placeholders for nutritious foods that are plants, which come with fiber and lots of minerals and vitamins and so on and so forth. Fish is the one animal protein that appears to be nutritious. And so I have fish about 2 to 3 times a week. So let's talk a little bit about the difference between animal versus plant proteins, really, or foods. The main difference is fiber. Animal proteins are protein and fat, mostly saturated fat. Some animal proteins, like eggs, are protein and cholesterol. Egg whites are protein only. Plant proteins, and when we say plant proteins, we're talking about all plants. Okay, I want you to get away from this idea that you have to have tofu to have plant protein. Anything that was alive at one point in time as a plant has to have protein as part of its makeup, because protein, carbs, and fats are the 3 molecules of life. In fact, if you get all of your daily calories from broccoli, so 1,500 to 2,000 calories from broccoli, I don't suggest you do that because you're going to feel sick. But if you got all of your daily calories from broccoli, you would get the USDA approved amount of protein. So we have to separate this idea that protein has to be part of our plate, the way that the sort of Western culture has ingrained and broken our plate down. Animal protein, protein and fat, plant protein, and so the things that are high in protein, having said that, are beans, nuts, seeds, whole grains, and then a bunch of vegetables that have more protein than you think, like broccoli, kale, mushrooms have significant amounts of protein. Plant proteins are protein and fiber. Some plant proteins like nuts, seeds, avocado, and such have poly and mono unsaturated fats, and some of them have a little bit of saturated fats. But the main difference between animal proteins and plant proteins are protein and fat versus protein and fiber. What happens when you move from animal protein to plant protein is you create caloric space in your diet to eat more fiber. You can't add fiber to a regular diet because you're going to get bloated. You have lots of animal proteins in a regular diet that is moving through the gut very slowly and breaking down very differently. We'll talk about that in a little bit. And fiber will make you bloated and not feel well. You can increase the amount of fiber by creating caloric space to eat foods that are high in fiber. The average American diet has about 15 grams of fiber a day. A very healthy Mediterranean style high fiber diet is going to have about 30 grams of fiber a day. A whole food plant-based diet plus fish 3 times a week on average per day will have about 70 to 80 grams of fiber a day. I know that because for a week I tracked my diet with one of the smartphone apps, MyFitnessPal, and on average I was having somewhere between 70 and 80 grams of fiber a day. So fiber, we'll again talk about this, is important because fiber is the prebiotic, the food for the probiotic, the bacteria that lives in your gut. When you feed your gut bacteria fiber, the fermenter bacteria species that eat fiber get very healthy. They have a lot of food. They flourish in the gut. And the non-fermenter protein-eating bacteria, proteolytic bacteria, die off because the fermenters are sort of winning the Darwinian evolution. So fiber is very important. We're going to get back to that. Caloric density. Fiber is very calorie non-dense. It fills you up. It's helpful for weight loss. Fiber is very important for gut motility. Why is gut motility important? If you look at our total gut length to body surface area ratio, so you cut open, you take your intestines, you stretch them apart, and then you compare it to your body surface area, and you look at all animals and you put it on a graph, there's a trend where herbivores, pure plant eaters, which evolutionarily we are not, herbivores will have very, very long gut length to body surface areas. Think of cows. Obligate carnivores like cats will have very short gut length to body surface area. When you compare ours to all other species, we fall somewhere around 80 to 90% plant fiber products and 10 to 20% caloric daily intake of animal products. And that's important because you need a very long gut to break down fiber, much of which is difficult to digest, insoluble, and so on and so forth. Now, when you have a long gut like we do, and you don't have enough fiber, food moves through the gut because of fiber. Fiber comes into the intestine. It swells the intestine when it absorbs water. The muscle of the intestine swells. And when that muscle swells, it's like a knee-jerk reaction. When the doctor hits your knee, your foot goes up. That intestine, when it swells, it spasms, and that peristalsis moves food through the gut. When you don't have enough fiber in the gut, food moves through the gut very slowly. And so transit time is a direct correlative function of the amount of fiber in your diet. The more fiber, the lower the transit time. When you have animal proteins in your diet and you have long transit time, think about what happens to animal proteins when you leave them on your kitchen countertop. You can't eat them the next morning. Why not? Because they're rancid. What does that mean? That means the bacteria that break animal proteins down cause toxins, acids, and a whole bunch of stuff that'll make you sick. Well, what do you think happens to undigested animal protein that passes your stomach? And about 10 to 20% of all protein that you take ends up in your colon in its elemental protein form, meaning it doesn't get broken down into amino acids and absorbed into your body. That same process of going rancid is happening at a much faster pace actually in your gut. So once that protein gets to your gut, it's now inflammatory and acidic and activating the immune system. I'm gonna show you a slide about that. What happens to plant proteins when you leave them on your kitchen countertop? Nothing. They will wilt, they'll dry out. Sometimes fungus grows on them. We call it penicillin. It's not bad for you. And if you keep them wet, they'll pickle, but usually it's unusual for them to get rancid in that way. So let's, animal proteins versus plant proteins. Protein decomposition is different. animal protein amino acids have sulfate groups on them. Sulfate gets changed to hydrosulfuric acid in the body. Hydrosulfuric acid is very acidifying, will acidify your urine, acidify your blood. Acid is bad for bones and for a whole bunch of other body metabolites. Plant proteins don't have hydrosulfuric acid in their sulfate groups in their amino acids. You don't make hydrosulfuric acids. Plant acids like citric acid, vitamin C, you can take grams of vitamin C and it will not acidify your blood system. And in fact, Linus Pauling, famous Nobel laureate, believes in that. I don't, but bottom line, their acidifying potential because of biochemical properties is much, much less. There are other effects of protein decomposition that have to do with the kinds of amino acids that are found in animal proteins versus plant proteins, which I'm not going to get into, but are very interesting as well. Methods of cooking are very different between animal and plant proteins. Animal proteins require high heat cooking, direct frying, direct flame. Plants, you are cooking mostly at boiling water temperature because they're mostly made of water. And high heat cooking specifically of animal products creates nitrosamines and nitrates, which are cancer causing. Whereas when you caramelize onions, and you're doing that at a high heat as well, caramelization, even though it changes the structure of the sugars in the onion, you don't get cancer causing compounds in the same way. You have to be a little bit careful at what oils you're using when you're cooking at different temperatures, and we can talk about that. Evolutionary biology is relevant when it comes to animal plant proteins. I talked about the gut motility, the gut length to body surface area ratio. Our incisors, the fact that our jaw goes side to side and not just up and down. These are evolutionary characteristics of herbivores that eat nuts and seeds and grains and need to grind and don't have to tear meat and so on and so forth. And then very importantly, something that I think a lot of folks, even folks who talk about this stuff, don't really realize is variety of protein source. So when I talk about this for most of my patients, I ask, we do a diet history first, and invariably, when you look at their regular Western American diet, they're getting about 80% of their proteins from 3, maybe 4 animal sources: chicken, dairy, eggs, and if they're healthy, fish; if they're not very healthy, meat. You can't get 80% of your protein sources from the 3 same or 4 same plant proteins. You cannot say, I get my protein from chickpeas, walnuts, quinoa, and mushrooms, because you're going to get sick of them. They're not appetizing in the way that meat and eggs and addictive animal products are. They don't have the saturated fat that makes you come back for more. They're not satiating in the same way. And I've never met somebody that eats the same 4 plants. The key to that is that chicken is chicken is chicken is chicken. But lentils are different than chickpeas, are different than navy beans, fava beans, gigante beans, cannelli beans, blue beans, pinto beans. Walnuts are different than cashews, pistachios, almonds. Flax seeds are different than hemp seeds, chia seeds, and I can go on. And the difference, they're made of different proteins. They have different micronutrients, covitamins, minerals. These are the things that give foods different tastes, different colors, different textures. And the key to that is that every year you hear of a new compound antioxidant that's found that is the cure-all, end-all, be-all. Blueberries are the superfood this year. Chia seeds were the superfood last year. Raspberries or blackberries were the superfood the year before that. Each of these micronutrients have literally magical properties, especially when found in whole foods as opposed to supplements. When you diversify your diet, you diversify all of these protein sources and you increase the chance that you're going to expose yourself to something good. At the same time, when you diversify, you decrease the chance that you're going to expose yourself to something concentrated that's bad, which is what we described with animal husbandry process from 50 pounds of corn to 1 pound of beef. And I equate that sort of concept to crystallize it in my patients' minds when we would spray DDT to kill mosquitoes. We found out that bald eagles were dying. Why were bald eagles dying? Because they would eat the snakes, that would eat the rodents, that would eat the spiders, that would eat the mosquitoes. When you eat a cow, you're literally on top of you're the bald eagle. You're eating everything that cow and all of the processing beforehand has been exposed to. When you move up the food chain and you go back to plants, you're diversifying your exposure. Now, plants, farmers use chemicals and pesticides and all that kind of stuff. But whereas 90% of the chicken in the United States anyway comes from one distributor, 80% of the eggs come from one distributor. When you buy plants, you tend to buy seasonal, what's in season. You tend to buy stuff that's local, and it's just a lot more diverse as far as the way food industry is now. So variety of protein sources, I think, is very important for health as well.
Hooman, we have a question, if we may. Tim Wong asks, are canned or frozen whole foods just as good as fresh?
Sometimes they can even be better in that frozen blueberries, for example, those blueberries are picked at prime ripeness and frozen right away, as opposed to blueberries that you buy in the supermarket, which may have needed to be picked earlier. So I like to have fresh stuff all the time because I'm uncomfortable with the packaging that comes with canned foods. Even though it might say BPA free can, I just hate the idea that food has been sitting in something like plastic or so on and so forth. So my blueberries in my morning shake that I have every morning is frozen. Both ways, but I think, it's also what I would say is whatever you can get your hands on, whatever fits your budget and whatever is convenient. I would not focus so much on those minutia kinds of things and lose the big picture, which is to move towards a whole food plant-based diet. So what's the data? I gave you some foundational concepts of the medical significance of some of this stuff, but how about scientific studies? This is a meta-analysis that looked at all studies that have fiber as a pre-specified part of their dietary component. And these studies also pre-specified had heart disease as an outcome. And there are, literally hundreds of studies. And when you plot the studies and the estimated relative risk of a cardiovascular or cerebrovascular event, you start to see that the more fiber grams per day in the diet, the lower the risk of heart disease. Average American diet, 10 to 15 grams. Mediterranean diet, 25 to 30 grams. Whole food plant-based diet, more than 60, 70, 80 grams of fiber. Vascular health is the key to all health. You want to reduce your chance of dying from COVID? Take care of your blood vessels. Your blood vessel, whatever keeps your blood vessels healthy and happy, is going to keep you from getting cancer, Alzheimer's, neurologic disease, inflammatory disease, immune disease, infectious disease. Vascular health is the ultimate end-all be-all, because every single cell in the body has access to a blood vessel. And that's how life works. So this is cardiovascular disease and fiber. This is what happens with plant. This is another meta-analysis, conglomeration of many different studies that have looked at plant-based diets and cholesterol levels. And we see average reductions in LDL bad cholesterol in American units of around 25 to 30, which is similar to a moderate dose of a statin like Lipitor, Crestor, rosuvastatin, atorvastatin, so on and so forth. Now, all of these studies that I'm showing you looked at plant-based diets. Most of them are epidemiologic studies. I'll show you the randomized prospective studies in a second, but they are not studies of whole food plant-based diets. Plant-based diets could be white bread, jam, and soda. That's a plant-based diet. And I believe that a whole food plant-based diet has even higher benefits than what these studies suggest. And I'll show you that in a minute. This is what plant-based diets, specifically vegetarian diets, there are similar graphs for vegan diets, does for blood pressure. Meta-analysis lowers blood pressure by about around 8 to 10 millimeters of mercury, which is the same as a moderate dose of at least one blood pressure medicine. So let's talk a little bit about plant-based versus whole food plant-based. This one study is a very important study published back in 2017. The Nurses' Health Study and the Physicians' Health Study are the largest prospective randomized placebo-controlled trials that we've done in medicine. And they looked at many different things: aspirin versus no aspirin, cholesterol versus statins versus no statins, hormone replacement therapy versus no hormone replacement therapy, and looked at outcomes. What this group came and did is they said, okay, we have an opportunity to follow 200,000 people prospectively. When they enter the study, no matter what group they're in, we're going to give them food questionnaires. And because they're in the study, we're going to measure every single thing that happens to them because they're part of the study. And here's a great way to see what correlates with what. And what they found, they created something called the plant-based index. They broke that down between a whole food plant-based index, a regular all plant-based index. Anytime you eat a plant, soda would include as a plant-based product. You get a +1. But then they broke that down between a healthy plant-based index, which is a whole food, and unhealthy. Think of chips, bread, soda, juice. And what they were able to show is that overall, the more plants you eat, the lower the incidence of heart disease. But if you break it down between healthy plants and non-healthy plants, eating non-healthy plants, the more of those that you eat, processed foods, the worse that you do. Put it a different way, maybe this is easier to understand. If you just break down foods that people eat on a daily basis into animal foods, less healthy plant foods, and healthy whole plant foods, the more whole plant foods you eat, the linearly better health that you have. The more animal foods you eat, linearly the worse health you have. They included dairy in this group. But the more processed foods you eat, it's even worse than eating animal protein. So if you stop eating chicken, but you're eating regular pasta as the replacement, you're not helping yourself, okay? If you stop eating meat and start eating, bread with jam, you're not helping yourself. We're talking about whole food, plant-based proteins. And these include fish as part of the animal foods. So there's many other studies that have tried to isolate fish from other animal proteins, and fish is supposed to be healthy. At the worst, it's neutral, but there's a lot of data that suggests that it's healthful. Okay, those are heart disease. How about cancer? Well, this is meta-analysis of those multiple studies that pre-specified. So this is not a fishing expedition and they go back and look at data and try to see what they find. They knew in advance that they're going to be looking at these outcomes. And when you look at all-cause mortality, definitely heart disease and cardiovascular mortality, but when you look at different kinds of cancers, they fall to the left of the line of equivalence, meaning that plant-based diets are better. And again, they're not talking about whole food plant-based, they're just talking about plant-based. So these effects, I think, are underappreciated. Put it a different, yes.
Could I interrupt for a couple of questions? Or
yes.
Okay, so there's three, if we may. So Camille asks, you mentioned fish. Does that include things like shrimp and crab?
It's a great question. Typically, the fish that have been best studied are the oily fish like salmon and bronzino and whitefish and things like that, mackerel, tuna. I look at shell, and the answer to your question is I don't know. Nobody knows. I look at shellfish as treats. So during the summer, I'll have shellfish like once a week, at most, probably once every 2 weeks, but they're not foundational parts of my diet. So when I say fish 2 to 3 times a week, I'm talking about bronzino and salmon and sardines, anchovies, which have lots of calcium in them, including sardines, maybe some tuna fish, canned tuna. Was there another question?
Yes, we have a couple more. So there's a question about, in a country like the US with high rates of poverty and obesity, what are some foods that low-income people could afford in order to eat a healthy diet?
Absolutely. So classically, these foods were called peasant foods. So peasant stew of any culture of your choice is the stew of that culture that has no animal protein. Because animal proteins used to be the most expensive part of the diet. That's gotten flipped on its head because of modern animal husbandry. What I would say is rice and beans are very, very inexpensive. And buying dried beans and rice and whole grains in bulk are, very inexpensive. It takes a bit of planning. It's not the kind of food that you can go quickly in a fast food restaurant and get. I do, make my own breakfasts now, make my own lunches now, because I know that when I make my shake, it costs me, $1.50. When I buy my morning shake, it costs me $10.50. Same with that stingy little salad, that I'm served at Chopped or so on and so forth. Those places that are selling you healthy foods are selling you the health. But if you look a little bit deeper and figure out how to buy these foods in bulk, share amongst friends and family, those are some ways to cut price. But surely what you're talking about and your question is very, very important. And a lot of that has to do with the way that we subsidize foods, specifically in the United States, as far as congressional subsidies, and how sugar is much, much cheaper and corn is much, much cheaper than it really should be. Is there another question?
Yeah, thank you. There's a few, but maybe in the interest of time, we can leave them for the end, perhaps?
Okay, sure. So I'm going to try to get through this because there's a couple of slides that are really interesting. This is the most modern randomized prospective trial called the PREDIMED study. The PREDIMED study was a randomized trial between the American Heart Association Heart Healthy Diet, which is as good evidence as our associations suggest, versus a Mediterranean diet plus nuts or a Mediterranean diet plus olive oil. And they were able to show this, it's not on this slide, but they were able to show that the Mediterranean diet plus olive oil has less heart disease, as well as a whole bunch of different cancers, and then the Mediterranean diet plus nuts. And then the worst was the American Heart Association diet, which has a bunch of animal proteins. The main difference between the Mediterranean diets and the Western diets were more fish, more whole grains, more fresh fruits and vegetables, more beans, and less animal proteins. And specifically nuts and seeds were supplemented. What these folks did is, again, at time zero, they gave out food questionnaires to all people, all groups. They put them into baskets of pro-vegetarian food pattern. Number 5 being the folks who ate the most plants, the least animal proteins, and vice versa on 1. And then they followed their mortality. And what they found, interestingly, is a dose response curve. The less animal proteins you eat, the lower mortality you have. Now, this is, rates per 1,000 person years. So, this is not 8% versus 10%. This is 0.08 versus 0.0 or 0.008 versus 0.01. But when you extrapolate to the population, these are, millions of people in the world. In the last 5 minutes or so, I'd like to talk about the gut microbiome. And to introduce that topic, we're going to talk about a compound called TMAO. TMAO has been known for about 30 years to be inflammatory, cause kidney disease and heart disease. It was found in Framingham studies when they looked at blood work and tried to correlate what factors in blood lead to disease. They didn't even know what TMAO was. Years later, they figured out that this compound that they found in gel electrophoresis, because it's a protein, is a breakdown product of L-carnitine and choline. The two, L-carnitine is called carnitine because it's found exclusively in meat. Choline is found in chicken. Choline is also found in fish and eggs. And they said, okay, well, that sort of makes sense. We know that meat is bad for you, and we know that cholesterol is not the end-all be-all, that it's only one factor. There are people with high cholesterol, they never get heart disease. Maybe some other factor in meat is TMAO. This study showed definitively that at time zero, when you take 4,000 patients and you measure their blood and you put them into baskets at time zero of highest quartile versus lower quartile of TMAO, and then you follow them over the next 3 years, you can show independent, and these curves are controlled for blood pressure, cholesterol, smoking, diabetes, all of the risk factors that we know cause heart disease. Independent of those things, TMAO is a wonderful predictor of who's going to have a 20% chance of having a heart attack versus who's going to have a 7% chance of having a heart attack in 3 years. These were relatively high-risk people. That's why the chance of having a heart attack in 3 years was so high in this group. So TMAO closely linked, purified TMAO, feed it into animals. Rats develop heart disease, put TMAO on a petri dish. The endothelial cells lining of blood vessels in the petri dish become inflamed. So the next question is, How is L-carnitine broken down into TMAO? What are the levels? What's the half-life? Which organ gets rid of it in your body? And to do that kind of study, that's called a pharmacodynamic study. You need a system that's clean, that has no TMAO in it. So then you introduce the precursor of TMAO, it gets broken down, and then TMAO equilibrates between different areas. And then you need a system that already is in equilibrium. The natural experiment is omnivores versus vegans. When you feed omnivores steak, so they took a group of omnivores, they fed them steak, measured their TMAO level beforehand. It's a little bit elevated. They eat steak, their TMAO level goes up to 6, or sixfold, I should say. Vegans eat the same exact steak. Their TMAO levels before are undetectable. Same period of time, their TMAO levels do not go up at all. Well, how could this be? I see a lot of perplexed faces. I was confused when I first looked at this as well. We have humans. We're feeding them the same thing. How come we can't measure? And it's not like there's inter-individual variability. As a group, they're completely different. These folks are not alien. These folks are not all brothers or sisters or cousins. So it turns out that L-carnitine specifically, and choline probably, is a Darwinian selection pressure for gut bacteria. And this is a very important concept, so I'm going to just take a little bit of time explaining it. When there's L-carnitine in the diet, there are bacteria that use L-carnitine as a food source. They extract energy. They break L-carnitine to something called TMA. We absorb TMA, and our liver detoxifies TMA into TMAO. When there's a lot of L-carnitine, that bacteria has a food supply. Darwinian evolution, they start to take over our gut. When there's no L-carnitine, those bacteria that have that gene that allows them to use L-carnitine are at a selective disadvantage. When there are giraffes, but there's no tall trees, they all get eaten up and they starve, and they hit their heads when they're crossing bridges and stuff like that. So those bacteria go away. And the factory line that takes L-carnitine and makes TMA, and therefore TMAO, is not there. Put it a different way, when you take the omnivores, you take away meat completely, and you give them the same exact piece of steak at 6 weeks, this is their curve, the vegan curve. When you take the vegans and you give them L-carnitine steak every second or third day, at 2 weeks, their TMAO levels start to go up, and at 6 weeks, this is their curve. Everybody can see my cursor? So let's take a couple of steps. Some are slightly philosophical, so bear with me. But if your genetic makeup is your blueprint of who you are, your color eyes, color hair, as well as how you make cholesterol, if you line up all of the genes, and so take one step back from there, it turns out 1/3 of metabolites that we measure in the blood, for example, TMAO is one of them. High sensitivity C-reactive protein, marker of inflammation, is another. 1/3 of things that we measure in the blood are directly related to gut bacteria, not to our cells or genes. It's gut bacteria that determine their levels. If you line up all of the genetic makeup on you right now, there is more genetic material, DNA, on Tim that is bacteria than is Tim. When you change what you eat, you genetically change who you are. When I understood this on a scientific, biologic, physiologic level, it literally blew my mind. And there is study after study after study that shows that when you change your microbiome, you interact with your environment differently, even for the same stimulus. In the interest of time, I'm going to leave that there. I'm going to skip over this. And then this is the last real main slide. And then Tim has a lot of very important things to say. Tim, do you want me to stop and let you talk and come back to this, or do you want me to go through this? You're muted.
Yeah, I think we're already losing people, so maybe we should move ahead. There are some questions. Do you want to do those at the end, Eliam, or do you want to answer a couple?
I think let's do the questions at the end, and
Okay.
Also thank you everyone for joining. If we do understand that you may have plans, and so if you do need to get going, that's okay. I hope that that you won't, but yeah, thank you. Continue, Hooman. Thank you.
Tim, did you want to go through? Do you want me to fast forward to yours, and then we can always go back?
Yeah, and as he's fast forwarding, again, you know, what he's doing is making the case. If you want to enhance your life, lengthen your life, if you want to have less cancer, less heart disease, think about what you eat. You are, in fact, what you eat. Oh, by the way, as a side benefit, the planet's health is impacted by what happens when you make eating choices. I'm not going to talk a lot about what the planet's health is, other than to say, call or talk to me at a later date. Things are starting to happen in a big way. Fires, tornadoes, droughts, all these things are being generated basically because we've, go to the next slide, have not been mindful of the planet's health. This isn't, you know, a thing that people have not talked about. Literally, our US government released a report in November 2018, 4 years of research, the Defense Department, the Commerce Department, the Energy Department, 10 other departments, 300 scientists, basically said, climate change is happening now. If we don't act now to protect current and future generations, there's going to be dire economic, social, and environmental costs that will be enormous and long-lasting. Next slide. What's the cause? This is the slide on the left side shows what's going on with carbon dioxide. It goes back 500,000 years. 500,000 years. We've never had the concentration of carbon dioxide in the atmosphere that we do today. We're at 400 parts per million and climbing at dramatic rates. What's the cause of that? The slide or the graph on the right shows what's happened to the global mean temperature. Temperature is rising globally as a result. Next slide. So if you want to take care of the planet, there's really 100 things we need to do, but probably bucket them into 5 different things: transportation, electricity, production of electricity, industry use of energy, commercial and residential energy use, and agriculture. The point is, agriculture is a significant player in the scheme of things. Next slide. Biggest driver is meat production. If we reduce the amount of meat that's being eaten, you end up with more land that's been cleared to have plants and or trees. There's less fertilizer use, which is today produced mostly as a byproduct of hydrocarbons. There's less burping cattle, less greenhouse gas emissions. This slide got a little bit goofed up here in the translation here, apologize for that. But in the pie chart in the lower right-hand corner, you can see that meats and dairy, the 2 things that Hooman is suggesting you minimize consumption of, are the biggest producers of greenhouse gases. Everything that you eat has some impact, but you get rid of literally 60 to 80% of the greenhouse gas production if you eliminate meat and dairy from your diet. For the average person, that elimination is around 5,500 pounds of CO2 production. Each one of us, if we're typical, is producing 5,500 pounds of CO2 by eating meat, and another 1,800 pounds of CO2 by eating dairy. Next slide. What can you do to intervene on the climate? Again, these are the 5 top action items. Buy renewable energy for home electric, buy a plug-in, convert to a plant-rich diet, waste less food, use less energy in your house, things like LEDs and insulation. The point is, not all of us are going to be able to contribute in all these ways, but virtually everybody can contribute in terms of eating a plant-rich diet and wasting less food. And both of those are big levers as we look at the future with our situation with greenhouse gases and the impact it has on our world. And I think that's the last slide. Is that right? Oh, why did I get excited about this? There's 8 kids, all those Connors kids. I don't want to leave them a bad world. I want to leave them a good world. And right now we're tracking towards not such a comfortable world. So when I think about this, I think about these kids and my duty and my responsibility to them. And that is the end. Back to questions.
Thank you. Hooman, would you like to take a couple of minutes to wrap up your part, or should we do questions?
Let me do this slide because this really, is as important as any of the slides before. We were talking about the microbiome, and to study the microbiome is really difficult because you care about the bacteria that live right next to the gut cells. It's the microenvironment, and that's not the bacteria necessarily. That's the same that's coming out in stool. So to study the gut bacteria, you got to cut gut. And you can't do that with humans. So you can set up a humanized mouse gut model. You birth the mouse or a rat into sterility through C-section. You put human gut bacteria into the mouse into the mouse gut through lavage, and then you feed the mouse different things. And then you can take the intestines out and do a whole bunch of studies. And so what this study that was published in Cell, which is one of the main scientific medical journals ever, shows that when you have a lot of fiber in the diet, fiber-eating bacteria eat the fiber. They make something called short-chain fatty acids. Butyrate is one. That's what's supposed to be in bulletproof coffee. Butter, has a lot of butyrate, but butter has a lot of bad things too. Short-chain fatty acids, it turns out, is the main food source for gut cells. When gut cells have short-chain fatty acids, they make something called mucin, which is a goo, a slime, a proteoglycan. That slime is the barrier between outside and inside. When you don't have a lot of fiber in the diet, and obviously these are extremes and there's a continuum, fiber-eating bacteria die off. I talked to you about proteolytic protein-eating bacteria do better. Guess what? This is a proteoglycan. They start eating the barrier. The gut cells don't have short-chain fatty acids. They make the mucin. The barrier starts to break down. There's interaction between outside and inside. This is what lay people call the leaky gut syndrome. When there's interaction between outside and inside, the immune system is activated. Your immune cells line the inside, the self side of the gut, because that's the main place where outside comes in. Your skin is a barrier, but it's designed to keep outside out. Your gut is a barrier designed to bring outside in. So as a result, a lot of immune cells, some people believe that most of our immune system actually lines our gut. When this barrier breaks down and there's interaction between outside and inside, these immune cells, which this picture doesn't show, get activated. They then start the inflammatory cascade, and inflammation is the first domino to fall in all modern day diseases. Heart disease, cancer, Alzheimer's, so on and so forth. These are all inflammatory diseases. So this is one way that fiber keeps the gut healthy and your microbiome self-relationship intact.
Fantastic. I take it that's, shall we take questions now, Hooman, or I don't want to interrupt? Yeah.
Yeah, no, let's take questions. I'm happy to send around, some resources. People always leave with questions. I tell them to watch the documentary I would tell them to watch the documentary Forks Over Knives. There's a new documentary called The Game Changers. That's a good one to watch, especially for folks who like to work out and build muscle and so on and so forth. I need to build muscle. Where do I get my protein from? And that's a good documentary for that. These are some good books. I tweet about this stuff. This is the only thing until COVID that I tweeted about. And then there was a time that I only tweeted about COVID. Now I'm starting to get back to dietary, health benefits. There's a menu that I can share with Eliam that she can post as well. That is a sort of sample, 3 or 4 things for breakfast, 3 or 4 things for lunch, for dinner.
Perfect. Yeah, if it's okay with you both, I'll send out the slides after in an email, and so they can access all of these resources. So for questions now, if we could, it'd be nice to hear your voices rather than me speaking for you all. So feel free to raise your hands, or Camille, do you want to ask a question? Yeah.
So 2 questions. One is, you mentioned earlier in your presentation, Hooman, about supplements. So what are your thoughts on, I take a multivitamin supplement. Is that worth it? Should it be specialized?
If people are eating a healthy diet, especially if there's lots of fresh plants and fruits and vegetables, beans, nuts, seeds, grains, the only 2 supplements that I check levels of and then supplement if deficient is B12 and vitamin D. B12, even folks who are in a very high animal protein diet, B12 levels are typically low in modern populations because of modern farming techniques. Soils used to be very rich in B12 because B12 is found in bacteria, and soils used to be very rich in bacteria as fertilizers, but because now soils are fertilized chemically, plants don't have a lot of B12, and therefore the animals that eat the plants also don't have B12. So B12 and vitamin D are the 2.
Okay. And then my other question
for women would be calcium. Now, calcium is a separate issue, and I have a separate talk about calcium, plant-based diets, and osteoporosis. And it turns out that, first of all, you can eat a plant-based diet and get enough calcium. You just have to do a little bit of planning. Sometimes a small calcium supplement, like 500 milligrams of calcium, is recommended. But plant-based diets, specifically because they're low acidic diets, when the blood becomes acidic, the body buffers the blood acidity by taking, one of the ways the body buffers is by taking calcium out of bones, the same way that you take calcium carbonate or Tums. The body takes calcium out of bones to buffer the blood acidity. And once calcium is taken out of bones, it cannot be put back in the right way. And that's why all of the modern osteoporosis drugs that we have are helpful, but they're not really groundbreaking drugs. And there's multiple studies that show the more proteins in your diet, the more calcium with an R coefficient of 0.8, it's a pretty tight correlation, the more calcium gets excreted in the urine because it comes out of the bones. And if you look at world incidence of osteoporosis and you plot it on a graph, the incidence in the world of osteoporosis plotted on a graph, this may not show up very well, but if the x-axis is the amount of calcium in the body and the y-axis is rates of the amount of dairy in the diet and the amount of osteoporosis, these are the dots. I don't know if you can see it, but Traditionally, diets higher in calcium are associated with societies with higher osteoporosis rates. And the reason for that is not because calcium causes osteoporosis, but the amount of calcium in your diet oftentimes is a surrogate, a proxy of the amount of animal protein in your diet because of dairy.
Fantastic. Thank you. I realized that maybe before, in case people start to leave, I wanted to thank Hooman and Tim for being with us today. And thank you for a very interesting talk. Sometimes my brain has had to do some acrobatics to get around all the information, but I think it's like slowly entering my brain. So thank you. Livy has a question. And if other people have questions, please raise your hands or let me know.
Yeah, I had a question. I know that there are many negative effects of having a lot of meat consumption within your diet. Are those negative effects reflected in lab-grown meat?
Very good question. We don't know, I would say. I'm not very familiar with the amount of chemical processing that's involved in growing meat in a lab. Surely, as it pertains to saturated fat and the specific amino acid formulation, those are going to be the same, and those should have the same effects. So I would guess that they would have very similar effects. And I would think that lab-grown meat, if anything, would have higher exposures to hormones and growth factors and so on and so forth. I would also say I am not a fan of any of the meat replacers. Impossible Meat, Beyond Meat. These are high in saturated fat. They're highly processed foods. I use them as novelty treats, just like I would use meat for. So if you are not eating meat because of ethical reasons, they're, good substitutes. But from a health perspective, I don't think, a slab of Impossible Burger is any healthier than a regular burger.
Thank you. I can't see any more hands.
You broke Tim's heart, Hooman. I do have another question if no one else does, but I'll wait.
I think go ahead, Camille. Oh, go ahead, and then there was one in the chat from before.
Okay. So Hooman, I hear a lot about, or I have been hearing about, like, mucus in your system is bad or it's a sign of not health. Is that related to the leaky gut you were talking about and that mucus in your intestine?
No, slightly different. The mucin in the intestine doesn't really make it up to the throat. What you are referring to is a byproduct of inflammation, and oftentimes mucus in the upper throat, lower throat, nasopharyngeal area is secondary to mild chronic inflammation, oftentimes because of acid reflux. There are subsets of patients, I know it happened for me. Dairy is something that thickens mucus. We don't understand exactly why, if it's related to acid or not. But for me, when I went plant-based, my acid reflux got a lot better. The times that I would clear my throat and so on and so forth, the upper respiratory inflammation improved. I would say that doesn't happen in everyone who takes dairy out.
Thank you. What if there was a question that I'm interested in myself as well, from Daniela Perez in the chat. And Daniela says, if we want to change our diet to be plant-based, should we go to a nutritionist first, or should we face this, or how should we face this change?
Yeah, so it's a process, and it has to be a personal journey. My experience with nutritionists, and I started to learn more about the diet because I would send patients to nutritionists, and I was never satisfied with the scientific sort of understanding of what was happening, and I decided to sort of look into it myself. This has to be something that is ingrown in you. You're never, almost never, going to make yourself sick by moving towards plants. So you don't need medical advice to move towards plant products, as long as you try to diversify things a little bit and, you know, pay a little bit of attention to eating foods from different parts of the plant kingdom. But a lot of it is going to be culturally, you know, appropriate. So, you know, what I have for breakfast is a shake that I make with blueberry, kale, peanut butter, banana, chia seeds, hemp seeds, flax powder, the banana and blueberries frozen. So it's like a frozen blueberry peanut butter shake in the morning, and you can't taste the spinach or kale, and the chia, hemp, and flax have omega-3 fatty acids, as well as a bunch of proteins and fiber. Or I'll make steel cut oatmeal with nuts and seeds, cinnamon, and peaches, for example. You know, so you have to, there's a bunch of Iranian stews that I make for dinner, Moroccan carrot and lentil stew. You have to figure out what fits your taste palette, your ethnic background, if that's relevant. But I agree with you that yes, a nutritionist can help, but it's a process. And I would, you know, suggest, if it feels overwhelming, just to take it one meal at a time. Say, I'm going to change my breakfast to a plant-based breakfast, and I'm going to do that for a month, and I'm going to, you know, use the rules of carb to fiber. I'm going to eat whole foods, and I'm also going to know that the first, you know, 2 or 3 things that I try, I'm not going to like as much as my, you know, omelet in the morning. But I'm not going to give up. I'm going to try until I find the thing that I love. And that's the key.
Fantastic. That seems like a great note to end on, unless we have any last minute questions.
Just a comment, fascinating story. I really appreciate Tim Connors inviting me. It was a fabulous message. Thank you very much.
Thank you so much, Frank. It's great to have you. Thank you, Hooman. Thank you, Tim.
I do actually have a quick question
yes.
for Tim. So Tim, I've been trying to buy more organic, going to the farmer's market. Are going to these smaller farmer market better or helpful in terms of the footprint, you know, buying chicken from a farmer's market versus like Purdue, where they mass market?
Yeah, if you look at the statistics, there is some savings, but it's almost insignificant. The big deal is get rid of the meat. And after you do that, get rid of the dairy. It's the process of creating that meat and creating that dairy that generates the vast majority, I think 98% of the greenhouse gases. Transportation is literally 1 or 2%. So the big deal is get rid of the meat, get rid of the dairy. With that said, you know, every little bit helps. There's no reason not to go to those markets if it's convenient.
Mm-hmm. Okay.
Fantastic. So I want to thank Hooman and Tim again, and thank you, Hooman, for all the advice that you have given us. I hope that everyone can take at least one piece and, you know, implement it in their lives.